This question is from GATE 2014 Mechanical Engineering paper, set 1. It's question number 53. For the given assembly, 25H7G8, match group A with group B. So in group A we have P is H, Q is IT8, R is IT7 and S is G. And group B we have 1 being shaft type, 2 being hole type, 3 is hole tolerance grade and 4 is shaft tolerance grade. Let's see what the match will be. Now this symbol 25H7G8. This is a symbolic representation to denote the hole and the shaft in the assembly, to denote the details about the hole and the shaft in the assembly in a very concise manner. So we can say that H here denotes the hole type. So this letter H is telling you that the hole type is of capital H type. There is a standard given for identifying the particular hole type, shaft type, the sizes and grades for the assembly. So H here clearly will denote the hole type. There can be oversized or undersized holes, and depending upon that this letter is being assigned. So capital H will tell you the hole type. Similarly, small g is telling you the shaft type. What these number indicates? 7 and 8. So being with hole type, this 7 will represent the hole tolerance, and it is in short written as IT. So IT7 is nothing but the hole tolerance being represented, and this 7 represents that hole tolerance is grade 7. Similarly, this 8 is IT8, that represents that shaft tolerance is grade 8. Hole tolerance is grade 7 and shaft tolerance is grade 8. This is the complete meaning of this symbolic representation for the assembly. So now we can match the appropriate entities in the group. From group A, H is representing hole type, so this is 2. Q is representing shaft tolerance grade, so this is 4. IT7, R is representing the hole tolerance grade, so this is 3 itself. And G represents shaft type, so this is 1. So we have P2, Q4, R3 and S1. Let's see in which option is this match given. This is given in option D, P2, 4, 3 and 1, yes. So option D is correct. To learn about the standard followed to give a symbolic representation to the assembly and its parts, you can refer to the NPTEL video, Terminologies of Limits, Fits and Tolerances from the course of Metrology. This course is by Professor Kanakuppi Sadashivappa. He is from Department of Industrial and Production Engineering of Bapuji Institute of Engineering and Technology. I hope this explanation will help you clear your doubt. Thank you.